If you remember how to do LRAM and RRAM, left-sided and right-sided rectangle approximation method, today we're going to look at MRAM, midpoint rectangle approximation method. What happens here is instead of using the left-sided height or the right-sided height, we're going to go up the middle, which is kind of going to even out our process. So, my favorite, we're going to be doing our x squared here, and I'm going to use 0 to 8. So visually, just a quick visual, if we're using that quadratic, if this is the rectangle that I'm going to use, this would have been my left-sided height, and this would have been my right-sided height. So we can see there, one is clearly over, the other is clearly under. But with the midpoint, we're going to go and use the middle height, and our rectangle looks like this. So we're going to have a little overestimation and a little underestimation. So it's actually going to be a little bit more accurate because we're not going to gain or lose so much area. So since we're going from 0 to 8, I'm going to go ahead and just build a table. So we're going to go 0, 1, 2. Okay. And we're using the midpoints and we're using 4 intervals. So what I'm going to do is I'm going to create my 4 intervals. And since we're using MRAM, the middle height, we're going to be using 1, 3, 5, and 7. So I'm going to take 1, plug it in. 1 squared is 1. 3 squared is 9. 5 squared is 25. And 7 squared is 49. So the base of each of my rectangles from 0 to 2, 2 to 4, they all have a base of 2. So a base of 2, and then I have a height of 1, plus 9, plus 25, plus 49. So 10, 35, so 84 times 2. Did I do that right? 10, 35, and 49. Okay, so I'm going to double that. That's going to equal 168 is my approximation using the MRAM. The cool part, when you have a nice interval like this, doing MRAM's not hard. We're just using that middle value. The issue, if this case, I would have said we're going from 0 to 4, and we're doing 4 intervals, and I need an MRAM, I would have had to gone in and used 0.5, 1.5, 2.5, and 3.5. That's when MRAM can get a little bit more tricky. But as long as we're using our midpoint height to estimate that area. So I've got a table here where we're going to do the same. If we were given this table and we were asked to do MRAM, they're not telling me how many intervals to use. Yeah, we could do one big interval, but we want to be as accurate as possible, which means the more we can use, the more accurate our answer is going to be. So I'm going to go from 2 to 8, 8 to 13, and 13 to 20. So we've got 3 intervals here. When you're given a table, I can't go in and say, well, I'm going to use halfway between 2 and 5, and then I'm going to average my height. We can't create any values. We can only use the values given. So that's why I'm going to do the 3 values, and I'm going to base this off of 5, 10, and 15. So 2 to 8, I have a base of 6 and a height of 9. 8 to 13, I have a base of 5 and a height of 1. And then 13 to 20, I have a base of 7 and a height of 8. I'm using my MRAM to estimate. So I have 54 plus 5 plus 56. So that's 59. I'm not even going to try to do that in my head. I was going to be cool, but I'm not. So that gives me 115. Okay? Second example here, using a table and our midpoint rectangle approximation method, MRAM. Okay? Let me know if you got questions.